Hi everyone. The previous classes we have already learned the phenomena refraction of light and what happens when the light passes through different media and how they refract and all. And in this video we are going to discuss that the refraction by spherical lenses. Then what are spherical lenses? A spherical lens is a transparent material bound by two spherical surfaces through which the light can pass. When the light passes through this surface of transparent material, it refracts or it bends. Then lenses are of two kinds. So as we already stated in the cases of mirrors, there are two mirrors, convex mirror and concave mirror, on the basis of the way they reflect light. The same way, lenses are also two types, convex lens and concave lens. And let us see how these two lenses they refract the light. So as I said before, the spherical lenses, okay, one is convex lens and two is concave lens. So as I said before, a lens is a spherical surface, okay, and the center of this lens, that is the optical center of the lens, okay, optical center of the lens, the middle portion of the lens. And these two lenses, as we know that this lens, as they move towards the edges, it becomes thin, okay, and both sides, as they from the center, optical center, towards the edges, they are becoming thinner. Then by the physical appearance, so we can understand that this is a convex lens, a convex lens which becoming thinner towards the edges and thicker at the center. Then second, a concave lens. By the shape we can understand that this is the center point, there is a middle point, the optical center of the lens, and towards the edge this lens becoming thicker, both sides. At the middle they are very thin. So by shape we can distinguish these two lenses like this, okay, and but they are not the same. That means they are not refracting the light the same way. They are refracting the light in two different ways. So as we know that the terms associated with the lens, okay. So when we take this a lens, the line, a straight line, that is passing through the optical center of the lens, okay. So this is the principal axis, okay. So the principal axis, a line which is passing through the optical center, and so as I said, these are a aperture of a imaginary circle. If we extend these both surface in this way, okay, in this way, so what will happen? You will get an ellipse or a circle, okay. You will get a circle. If we extend towards this corner, this another surface, so we will get another circle, okay. And if these two circles, then both they will have a center, okay. A line which is passing through this both center of curvature of these two imaginary circle, that is the principal axis of the lens. The same way, if this concave lens also, if we extend this aperture in this way, we will get a two imaginary circle, and both these circle will have optical center. A line that is passing through this optical center and the imaginary center of this imaginary circle, that is called the principal axis of the lens. Okay, this term is called center of curvature, but we generally do not use as a center of curvature, and that is the term 2f. Okay, 2f. Instead of center of curvature we use 2f. Okay, then if a ray of light which is parallel to the principal axis for a convex lens, any ray of light which is parallel to the principal axis, okay, what will happen? When it passes through the lens, it will refract, that means it will bend. The lens will bend the light, okay, at a point on the principal axis. Any ray of light which is parallel to the principal axis focus on a point on the principal axis, okay, and this point is known as F, that is the principal focus of the lens. The same way, if the incident ray is coming from this side, okay, this side, and this surface also can refract the light, then what will happen? Generally this will focus on a point on the principal axis, that is the another principal focus of the convex lens. That means what? A lens has two principal foci, plural, okay. A lens has two principal foci. One is in this side, the second one is the another side. So this is the incident ray and this is the refracted ray, okay, that all we know. We discussed in the case of mirrors, same. And the point F, okay, this is the principal focus on the principal axis, and again on this way, on this point, any ray of light falls on this lens which is parallel to the principal axis, they focus on this point F, or they converge at this point on the principal axis. Therefore, this convex lens is also known as converging lens. Concave lens. Since these two, any ray of light which is parallel to the principal axis, okay. So as we know that any ray of light which is falling on this lens which is parallel to the principal axis, and this lens will refract the ray definitely, but after the refraction of light, this ray of light has a tendency to move away from the principal axis, okay, move away from the principal axis. So therefore what happens? Any ray of light which is falling on this lens, which they are parallel to the principal axis, will definitely refract by the lens, but it will diverge from the principal axis. Therefore this concave lens is also known as diverging lens. So converging lens and diverging lens. And if we extend these refracted rays towards the backward direction, so these refracted rays appears to focus a point on the principal axis, and this point is known as is taken as the principal focus of the lens here. The same way, the lens has another principal focus on the another side, okay. So a lens always has two principal foci, okay, the left side and the another side. The next, image formation of lenses by using ray diagrams. When we discuss about the image formed by lenses by using ray diagrams, we need to consider three kinds of rays, as I said in the case of reflection. First of all, for a convex lens, a ray of light, this is the principal axis, a ray of light passing through the both lenses. Okay, for a convex lens, we take a ray of light which is parallel to the principal axis. So when any ray of light is passing through a lens which is parallel to the principal axis, as I already said, it will converge at a point on the principal axis. That point is known as principal focus. That means any ray of light, incident ray which is parallel to the principal axis, after refraction, the refracted ray will pass through the principal focus. That is the first ray we need to consider to track the image formed by a convex lens. And for a concave lens, you know that a ray of light which is parallel to the principal axis. So since it is a diverging lens, it diverges the ray after refraction. So there is, this ray has no intention to pass through the principal focus of the lens. But if we extend this refracted ray in backward direction, this refracted ray appears to pass through the principal focus of the lens. So then that means this principal focus is not a real one, it's a virtual principal focus. So that is the first ray we need to consider for in order to track the image formed by a lens for convex and concave. And second ray of light which is second ray we are going to consider is a ray of light which is passing through the principal focus. Okay, incident ray, we consider an incident ray which is passing through the principal focus of the lens. So when it is fall on a convex lens, so definitely the lens will refract it, and the refracted ray will be parallel to the principal axis. It always will be any ray of light which is passing through the principal focus of a convex lens. After refraction, it will be parallel to the principal axis. The same way for a concave lens, a ray of light which is appears to, okay, if the incident ray is incident on the concave lens and this ray appears to pass through the principal focus, okay, not really, okay, but it appears to pass through the principal axis, and then after refraction it will parallel to the principal axis, but it is the incident ray appears to pass through the principal focus of the lens. And third ray we need to consider is a ray of light which is passing through the optical center of the lens. If any ray of light which is passing through the optical center of the lens, and it will continue the direction without any refraction, that means the light does not refract, it will continue its path in the same direction. Then any ray of light passing through the optical center of a lens, here another ray of light which is passing through the optical center, it will continue its path without changing its direction. That means no refraction will take place in that case. So when we consider, or when we explain the image formed by a spherical lens, we need to consider minimum 2 of these rays out of 3. Then only we can track the image formed by a spherical lens.